Everyone, this question is about partial fractions. So before we do the partial fractions decomposition, you gotta make sure that this is a proper algebraic fraction, which means the order of the numerator must be smaller than the order of the denominator, which means the highest power of x in the numerator must be smaller than the highest power of x in the denominator after we expand, of course. So the order is 2, the order is 3, we're fine here. We can just use the partial fractions form here. So for the 1 plus x, we have to use this form. So just a constant divided by the divisor. And here we use the linear, so something times x plus c. So look at the a, b, c and the form here we have to use. And after you recognize which forms we have to use for the simple linear and for the unfactorizable quadratic, now all we gotta do is to multiply both sides by the denominator, so they cancel out. On the left we have only the numerator, and on the right, after we multiply, we have here we cancel out, we have a times 2 plus x squared, and we multiply, cancel out, we have bx plus c times 1 plus x. So now if you look at this part here, so we want to separate all the coefficients in different terms. So we're gonna expand bx times 1 plus x, c times 1 plus x. We have the abc separated in different terms. Now to find the abc, we have to use the zeros of the divisors, so the zeros of what we see in the brackets. So for 2 plus x squared, there is no way you can make this a 0 by plugging anything. Okay, so whatever you plug into the x value here, this term will not go to 0. But for x, we can just plug in 0. For 1 plus x, we can just plug in minus 1. So if you want to find the ABC as fast as possible, the only way is to plug in minus 1, because when we do that, we plug in minus 1, the term goes to 0, this term goes to 0, we can find the a right away. So after plugging in minus 1, plug in minus 1, plug in minus 1, this is what we get on the left. On the right, this is just 1 plus 2, which is 3. We can find the value of a. And after that, we've used the other 0, which is just 0 here. So if you plug in 0, we just have 4, this is 0, this is 0. If you plug in 0, this is going to be 2 times a, but we already know the a is 2, so 2 times 2. And when we plug in 0, this will be 0. And when we plug in 0, this will be just 1 times c, which means we can find the c. Now for the last coefficient, because we already have the two other coefficients, just plug in anything random, but we want to use something simple, so just use 1. So replace this, so replace all the x with 1. So when we plug in 1, we get 4 minus 1 plus 1, and if you plug in 1, this is 3a, but the a is 2. And if you plug in 1, we get 1 times 2 times b, we don't know the b yet. And when we plug in 1, we get 2 times c, we already know the c is 0, so this will be just 0. And we can find the b. So after you solve everything here, cancel out, and this is 6, you get the value of b. So therefore, the final answer is, this is the a, the b is minus 1, the c is actually 0. So this is the final answer. Alright, I'll see you again next time.